Okay, the first thing we're going to do here and working towards IP addresses and subnet masks and determining what part of the address is a network portion and which part is the host portion is we need to determine what our IP address is. And you simply do that by hitting start, run, CMD. As you can see here, you'll hit the OK, and it'll open up a command prompt window. In the command prompt window, you will type ipconfig or ipconfig/all. ipconfig and hit enter, and you should come up with the IP addresses the IP address of your system. Now in this case, we'll take note that ours is 10.111.2.50, and our subnet mask is 255.255.255.0. We'll then use this information to help us determine what network we are on. All right, remember our binary number line. What we're going to do is expand the IP address to its binary form. Now, IP addresses are written as 4 dotted decimal octets, and by that we mean here's the dot, and each of these are decimal. So we have dotted decimal. That's what it's called. Each of these are called octets because they're actually 8 binary digits in length. Even though they're written in decimal, the underlying factor is binary, and they're 8 bits in length. So we're going to expand each of these octets to their binary equivalent. Now, what would the binary equivalent of 50 be? Well, we know that 0 would be in the 128-bit and 0 in the 64. We would have a 1 in the 32, a 1 in the 16 to make 48, and a 1 in the 2 position to make 50. So our first number would look as such. Our second number would be a binary 2, which would look like that. Our third octet would be 111. So 111 minus 64, this will be 47. So 1 in the 32 position yields 15. 0 in the 16, and these numbers together all equal 15. So our third number would be 11101110. And our last octet is a 10, and that happens to be a binary 10. Now I'm having a little difficult time writing this with the size of screen we have. So I'm only going to write the first 4 bits. You know the leading 4 bits out here are zeros. So I'm not going to show these bits on that first octet. All right, the subnetwork mask now was 255.255.0, correct? How is that information useful? Well, in a subnetwork mask, anywhere binary 1s are appearing, binary 1s mean network. That means it's part of the network address, and binary 0s mean it's part of the host address. An IP address has 2 sections, the network address and the host address portion. And we're going to spend a lot of time on this later, so don't get too worried about it right now. But it's important to at least start a foundation with this. Subnet masks have binary 1s, and they all must be together. Notice all the 255 is what? It's a 1 in each binary digit. That forms a 255. It doesn't have to be 255. At least the last octet here, it could be something like 240 if that was the design. And that would be this in binary. But in our case, it just happens to be that all the first 3 octets are all binary ones. And a subnetwork mask is useful for determining which portion is network and which portion is host. That's all a subnet mask is for. In this case, it says the first octet is all binary ones. The second octet is all binary ones, and the third octet is all binary ones, and the fourth octet is a binary 0. So again, the first 4 bits of the first octet I didn't show, but the first 4 bits would be of the subnet mask would be all ones. The second octet would be all ones because of 255 in the second octet. The third octet would be all binary ones because the third octet is 255, and the fourth octet would be all binary zeros. Now when we do an ANDing function to determine what's network and what is host. Now you should be able to just look at this and say, since I've told you that binary ones are network bits, the only binary ones are in the first 3 octets, and they're all ones, so the network portion is what? It should be 10.111.2.0. Because the last octet is for host, not for networks, so when we're not going to use the last octet for network, we kind of just call it .0. So that should be our answer. Is that going to be our answer? Well, let's see. The leading zeros that are not shown here, when they're ANDed, what do they produce? Well, 0 and anything from your previous truth table lecture was 0. So the leading 4 bits would be zeros. And anything in a 1 and a 1 here would be a 1. A 0 and a 1 here would be a 0. 1 and 1 is 1. 1 and 0 is 0. So remember, ANDing, if it's not 1 and 1, it's a 0. So in other words, if I'm going to AND a number with all ones, what do I get? Well, I get the original number I started with, basically. In decimal, this is 10 dot, what is this? 111 dot what? Again, I'm ANDing this number with all ones, so that means I'm basically going to get the number here. That's dot 2. And now I'm ANDing this number with all zeros. Anything ANDed with a 0 is 0. So the last octet is all zeros. So the network address is 10.111.2.0. That is the network address. Now what if that number had been, instead of 255, 255, 255.0, what if we would have had 255, 255, 255.128? What would our network address then be? Let's take a look at this. If this was our IP address and this were our subnet mask, let's blow both of these numbers up into their binary equivalents. Oops. Made a mistake here. Okay, that's a binary 10, corresponds to this. As you recall, this was our 111. This was 2. And we're running out of room here. we'll just do it this way, 0010. And that is our 50. Now 255, of course, is what? It's all ones in binary. That's the biggest number as it can be for 8 bits. Same for the second octet, and same for the third octet. But 128, we know, is actually just a 1 in the first position and zeros in the others. Now we're going to AND these numbers together, and we get 10 over here in decimal, because if you AND a number with all ones, you get the original number. Same for the second octet, same for the third octet. For the fourth octet, though, notice we do 0 and 1. Well, that's a 0. Now we're ANDing the rest of the numbers with all zeros, which again, if you AND something with 0, we get zeros. So we get all zeros. What is the network address this time? Well, it's the same number. The difference being we have a different subnet mask this time. Now that may mean nothing to you right now, and it's okay if it doesn't. Later when we get to subnetting, this will mean something. Just remember, this is the process by which we determine which portion of address is network and which portion of an address is host. In this case, all the bits after this point here, or all the bits on this side, are host bits. And all the bits on this side are network bits. Take that away from this presentation. That's what you want to get. Network bits on that side, host bits on that side. The subnet mask tells you where the network bits end. All ones mean a network bit. All ones here mean these are all network bits. All ones for 255 mean network bits. All ones for 255 mean network bits. 128 means only the first bit of the last octet is a network bit. These bits are host bits. And that's what that means.